Hello and welcome back. Let's talk about resistors. Electrical resistance is a fundamental concept in physics that quantifies how much a material opposes the flow of electric current. It is measured in ohms. According to Ohm's law, the relationship between the voltage and the current and resistance is V is equals to IR. This relationship tells us how the current flows through different components of a circuit depending on the resistance. In this lesson, we will focus on two common configurations: series circuits and parallel circuits. In a series circuit, all components are connected end to end in a single path, as the same current flows through each component. Let's look at the key features of series circuits. The same current flows through all resistors because there is only one path. Remember that the electric current is the number of charges per unit time across a cross-section of the wire, dq dt. And charge is a conserved magnitude. Voltage. The voltage across the circuit is the sum of the voltages across each resistor. Total V is V1 plus V2 plus V3 and so on. Let's look at Ohm's law to derive the expression of the equivalent resistance of a set of resistors in series. The total or equivalent resistance is the sum of the individual resistances. So total R is R1 plus R2 plus R3. There are some advantages of series circuits. They are simple to design and build. The more resistance is needed, resistors can be easily added in series. Disadvantages of these circuits is that if one component fails, the entire circuit is broken. For example, if a bulb burns out, the current is cut and all bulbs go out. The total resistance increases with each added resistor, reducing the overall current in the circuit. Parallel circuits. In a parallel circuit, all components are connected across the same 2 points, providing multiple paths for the current to flow. The voltage across each resistor is the same because all components are connected across the same 2 points. So V total is V1 is equals to V2 is equals to V3. All these pieces of wires can be seen as the same electrical point. The current arrives at the junction and finds different paths to follow. This distributes the current along all possible paths. Because of conservation of charge, the total current is the sum of the currents through each path. The current through each path resistor depends on the resistance. So the I total is equals to I1 plus I2 plus I3. Let's go to Ohm's law to derive the equivalent resistance of a parallel circuit. The total or equivalent resistance of a circuit is given by the reciprocal of the sum of the reciprocals of the individual resistances. So 1 over R total is equals to 1 over R1 plus 1 over R2 plus 1 over R3 and so on. There are some advantages here. So if one component fails, the rest of the circuit remains functional because the current can flow through other paths. Total resistance decreases the more resistors you add in the parallel. Disadvantage of these circuits, well, it requires more complex wiring compared to series circuits. The voltage remains constant, which may not be ideal for certain applications, although it might be for some others, of course. We can also have mixed circuits with some resistors in series and some resistors in parallel. To find the equivalent resistance, we should group the resistors step by step. For example, we could use series circuit for a string of lights, often used in older Christmas lights, but once one bulb is out, then the entire string stops working. We use parallel wiring in household electrical outlets, so they are wired in parallel so that each device receives the same voltage. In most modern buildings, lights are connected in parallel, so if one light fails, others remain on. So, to wrap up, the study of series and parallel circuits forms a foundation for understanding complex electrical systems. Series circuits offer simplicity but increase total resistance, limiting the current flow, and are vulnerable to failure in any component. On the other hand, parallel circuits maintain consistent voltage across components, reduce overall resistance, and provide resilience by allowing the system to function even if one path fails. Mixed circuits combine the strengths of both configurations, enabling precise control in advanced applications from consumer electronics to industrial power systems. Mastering these concepts is essential for designing efficient, reliable, and scalable electrical systems in modern technology. Thanks for watching, and may science be with you.